JUnit is a habit, not an afterthought. Appendix H, odds and ends. Odds and ends. Here I will go over stuff that was not covered in the course because it was minor or did not fit in the flow of the lecture or got omitted for other reasons. This appendix was added as the last section to the course when I realized that some material that would be nice to know was left out of the course's main body. I urge you to take a look at this appendix for the fun stuff it contains. You might say, wow, I did not know JUnit could do that. Let's go. Extensions available to you by default. There are 3 default parameter resolver extensions auto-registered by JUnit 5. TestInfo parameter resolver injects TestInfo instance into test class constructor or a test or lifecycle method parameter. Repetition-info parameter resolver injects repetition-info instance into add repeated tested before each or add after each. Test reporter parameter resolver injects test reporter into test class constructor or a test or lifecycle method parameter. Additionally, the built-in temp directory extension is used to create and clean up a temporary directory for an individual test or all tests in a test class. It is registered by default. To use it, annotate a non-private field of type java.neo.file.path or java.io.file with @tempdir. And if you recall, we covered this in lecture 4, but it never really made it into any of the labs or into other content. Or add a parameter of type java.neo.file.path or java.io.file annotated with @tempdir to a lifecycle method or test method. @tempdir is not supported on constructor parameters. If you wish to retain a single reference to a temp directory across lifecycle methods and the current test method, please use field injection by annotating a non-private instance field with @tempdir. You can also use @tempdir on a static variable to share it among unit tests in a test class. So @tempdir is still an experimental feature, but it works well. Test interfaces and default methods. JUnit Jupyter allows a test, repeated test, parameterized test, test factory, test template, before each, and after each to be declared on the interface default methods. Before all and after all can either be declared on static methods in a test interface or on interface default methods if the test interface or test class is annotated with @testinstance lifecycle.per_class. So according to the rules that we saw before. Turn off extension invocations for nested classes. Nested classes sometimes do not need to invoke extensions, but test class level extensions get invoked for them anyway. You can check if a class is a nested class in code in several ways depending on which class you are in. For example, test instance factory context interface has the getOuterInstance method. It is used in a test instance factory extension, for example, when we implement it. You can modify the behavior of an extension if you determine that it is currently being invoked on a nested class. That may be something you may or may not want, so use your judgment. To check if a class is an inner class, use extension context.getRequired test class and class getInclosing class methods of extension context and of classes respectively. A non-null return from the class.getInclosing class method will mean you are dealing with a @nested inner class as is being invoked by JUnit. Now let's talk about @tag syntax rules. A tag must not be null or blank. A trimmed tag must not contain white space. A trimmed tag must not contain ISO control characters. Excuse me. A trimmed tag must not contain any of the following reserved characters: comma, left parenthesis, right parenthesis, ampersand, vertical bar, exclamation point. Tag expressions. Tag expressions can impart complex behavior to their tag annotation usage and are very useful for building non-trivial test suites. Tag expressions are Boolean expressions with the operators exclamation mark, ampersand, and vertical bar or pipe. In addition, left parenthesis and right parenthesis can be used to adjust for operator precedence. Two special expressions are supported, any and none, which select all tests with any tags at all, and all tests without any tags, respectively. These special expressions may be combined with other expressions just like normal tags. Now at this point you're wondering where you can use tag expressions. Tag expressions are used within @include tags and @exclude tags annotations when composing test suites. The next slide will delve further into tag expressions. The exclamation sign operator means not and has right associativity. The ampersand operator means and has left associativity. The pipe operator means or and has right associativity. Tag expressions are used during test suite operation and can select complex tagging rules such as tag 1 or tag 2. This means all tests with tag 1 and all tests with tag 2. Tag 1 and tag 2. This means all tests with intersection between tag 1 and tag 2. Tag 1 and not tag 2. All tests for tag 1 but no tests for tag 2. Tag 1 or tag 2 and tag 3 or tag 4, separated by parentheses. All tag 1 or tag 2 tests for tag 3 or tag 4. So these tag expressions can get arbitrarily complex, but once again, the simpler the better. Using common build tools. JUnit is supported by Gradle and Maven. Starting with version 4.6, Gradle provides native support for executing tests on the JUnit platform. To enable it, you just need to specify use JUnit platform within a test task declaration and build.gradle. Starting with version 2.22.0, Maven Surefire and Maven Failsafe provide native support for executing tests on the JUnit platform. Please check out the documentation for these build tools for more info about them if desired. Your favorite IDE, well, IntelliJ IDEA comes to mind, more likely than not features integration between these build tools and JUnit out of the box.